Today I will talk about Chapter 6. Chapter 6 is about facility layout. So how to write, it means how to find out the right position for facilities, for equipments, for handling machines. So facilities layout, it means the configurations of departments, work centers, the right place for work centers, equipments, with particular emphasis, or we do emphasize on the movements of work, will be customers, materials, throughout or through the system. So we have to find the right place to allow the system to work too fast, to produce the highest volume of products. So, basic types of layouts. We can do layouts according to the product. That's why it's called product layouts. Or according to the process, the needed process to produce product, it's called process layout. Or according to fixed position layout. In fixed position layout, so we put our main product in a fixed position. We can't move the main product from place to another. So we have fixed position for the product, and we do all of the process around the product. Okay. Also, it is allowed to use combinations of all of the three layouts. First, product layout. Product layout, it means layout that uses standardized processing operations to achieve smooth, rapid, high volume flow of the product. So we have many steps. It's called stations or workstations. So we do the layout to produce the product, and the product moves from one workstation to another, from workstation 1 to workstation 2 to workstation 3 to workstation 4, and then it will be finished product. Okay, so design product layout. In this one, we have to concentrate on how to do line balancing. Line balancing, balancing for all of the line to produce the highest volume of products and decrease as much as we can the slack time or the idle time. Okay, so line processing is a process of assigning tasks to workstation in such a way that workstation have approximately equal time requirements. So we concentrate on decreasing the whole time needed to produce products by using workstations with equal time requirements. So, equal time is called cycle time. Cycle time, it means that the time consumed for every unit produced. So the difference between the different time between the first unit and the second unit, it's called cycle time. When we produce one unit, we have to wait the cycle time to produce the second unit. So cycle time is the maximum time, and also it is the maximum time allowed allowed at each workstation to complete its set of tasks on a unit. So this is the maximum time for any workstation to produce or to achieve the available tasks. Okay, how to count cycle time? Cycle time is operating time per day, OT, divided by desired output rate, D. So this is the way to get the cycle time. Also, if you would like to count output rate, it is operating time divided by the cycle time. Percent idle time, total idle time per cycle divided by number of workstations multiplied by the cycle time. If you would like to count the efficiency or the efficiency rate, it is 1 minus idle time rate. Okay, so the whole system efficiency rate, it is the 1 minus the idle time rate. Let's see exercise. Exercise about layout. Product layout. A firm wants to build a product line. Each product should pass 8 tasks. So we have 8 tasks must be performed for every unit of our product. Okay? So we have task A followed by immediate follower is B. The time to perform A is 0.2 minutes. Okay? And I have task B followed by E. And B needs 0.2 minutes to be performed. C followed by D. Okay? And it needs 0.8 minutes to be performed. Okay? D followed by F, and it needs 0.6 minutes to be performed. E followed by F. Okay? Followed by F, and it needs 0.3 minutes to be performed. Okay, F followed by G, and it needs 1 minute to be performed. G followed by H, and it needs 0.4 minutes to be performed. H, which is the last one, the last task, and it needs 0.3 minutes to be performed. So requirement. First, draw the precedence diagram, the flow diagram. Starts with A, ends with H. Okay? And then calculate cycle time needed to produce, be careful, 400 units per day if the firm works only 8 hours per day. Then determine the theoretical number of stations. Number 4, assign tasks to workstations. Assign tasks to workstation using the greatest number of following tasks. The greatest number of following tasks first. Okay? Calculate percentage of ideal time. Of course, efficiency rate of the line required also. So, how to draw the precedence diagram? See, this one starts with A. So we put A first. Task A first. And the A needs 0.2 minutes. Okay. B followed A. So we have to put B after A. And B time is 0.2 minutes. So the flow goes from A to B. So C hasn't any task before. It looks like A. Hasn't any, we can't start, we can put C in the beginning also, look like A. C needs 0.8 minutes to be performed. Okay? So D followed C. So we have to put D after C. D needs 0.6. D needs 0.6 minutes to be performed. So D after C. The flow goes from C to D. Okay? E needs 0.3 minutes. Be careful, E, it comes after B. So we have to put E over here. And it needs 0.3 minutes to be performed. So it comes after P. The flow goes from P to E. F. Okay? F, it needs 1 minute. Be careful, F came after D and E. So F, if we have F over here, it comes after D and E. So the flow goes from E and D to F. Why? Because F combine task E and combine task D together. Okay? So G, it comes after F. So G needs 0.4 minutes. G comes after F. H, it is the ending task. And it comes after G. And it needs 0.7. Okay? H, 0.3. The flow goes from G to H. This is how to draw the precedence diagram. It looks like this one. It looks like this one. See? Puts every task and the needed time to perform task up there or down there, no problem. Okay? After we draw the precedence diagram, okay, we can find the cycle time. Cycle time is the operating time per day, okay, in minutes. Why in minutes? Because the task time is in minutes. Okay, so operating time per day in minutes. So we are working 8 hours per day, 60 minutes per hour. So 8 multiplied by 60 divided by desired output rate. Remember, the exercise tells us that we must perform 400 units per day. So the cycle time is 1.2 minutes per unit. So we need 1.2 minutes to perform every unit. And the maximum time for any workstation is 1.2. This means that every station has 1.2 minutes for its assigned task. We can't give the workstation more than 1.2 minutes tasks. Okay, so this is the limited time or the maximum time for any workstation. So if we would like to count the theoretical number or the minimum number of workstations, how we can do that? So first of all, we have to get task time, the summation of all of the tasks time. See, all of the task time, the summation of all of it is 3.8 minutes. Is 3.8 minutes. Theoretical number of workstation is the total task time 3.8 divided by the cycle time we counted before, 1.2. So the theoretical number is 3.17. Okay? Equal or rounding is 4 stations. So we need at least 4 stations to perform all of the tasks needed. Okay? Now we can do assign tasks to workstations. So we have to construct table. Table says what? Says first column station, second column time remaining from every workstation. Time remaining from every workstation. The third column, eligible task. Eligible task to be taken in every workstation, according to the rule I have said before. Okay? Assigned task. So we have to select one of the eligible tasks. It's called assigned task. So the needed time to perform the assigned tasks. At last, we have to establish column for the idle time. Idle time, it is the slack time for every workstation. Unused time for every workstation. So we count that the cycle time is 1.2. Cycle time 1.2, it means that the maximum time for the workstation is 1.2. So we have to look at the diagram. We have to start our process with A or C. Because this one, it came, A or C, it came in the beginning. So we have time remaining. We didn't consume anything from 1.2. So time remaining is 1.2 minutes. Eligible task to be taken, A or C, as I said. Which one I have to take, A or C? Count the number of followed tasks. A followed by 5 tasks. But C followed by 4 tasks. So we will take the highest. We will take A, because A followed by 5 tasks. So assigned task is A. A time is 0.2. So we consumed 0.2 minutes from workstation 1. So the remaining time in the station is 1 minute. 1.2 minus 0.2 consumed by A. Remaining is 1. So eligible task. We have taken A already. So we can take C, we didn't take before, or B. C or B. C followed by 4 tasks. B also followed by 4 tasks. So they are equal. Which one we have to take? C or B? C time is 0.8, more than B time 0.2. So we will take C, the highest. Okay. So C time is 0.8. Time remaining in workstation. Time remaining is 1 minus 0.8 equals 0.2. So we already have taken A, C, AC. Remaining eligible is B or D. B or D. So P time is 0.2. D time is 0.6. Okay? The rule says we have to take the one who has many followed tasks than the others. Okay? So B has 4 followed tasks, but D has only 3 followed tasks. So we have to take P. B time is 0.2. Remaining time in workstation became 0. So we already have taken A, P, C. Remaining is E or D. So remaining time D or E. But we have consumed all of the workstation time. So there is no any idle time for workstation 1. So we have to open new workstations. We have to open new workstation, which is workstation 2. Its eligible time is 1.2, cycle time 1.2. Workstation 2. Okay? Workstation 2, its cycle time or its maximum time is 1.2. So, eligible task to be performed in Workstation 2 is D or E. So, we have to select one of them, D or E. Both, they have 3 followed tasks, but D needs highest time than, longest time than E. So we have to select D first. Its time is 0.6. The remaining time in workstation is 0.6. 1.2 minus 0.6 equals 0.6. So we didn't perform E yet. And we can't say F. Because to perform F, we need to finish E first. So E must be performed first. And it needs 0.3 minutes. So So remaining time in workstation is 0.3. And the followed task is F. Okay? And the F needs 1 minute. F needs 1 minute. So a remaining time is 0.3 in workstation 2. So we can't perform F in workstation 2. So 0.3 is the idle time in workstation 2. Workstation 3, its total time is 1.2. We have to perform F, and the F needs 1 minute. So remaining time is 0.2. We have finished F. Okay? The followed task is G. G needs 0.4. And remaining time in workstation 3 is 0.2. So we can't perform G in workstation 3. So the remaining time is 0.2 idle time. Okay, the last workstation 4, 1.2 maximum time. So we have to perform G. G is our needs 4 minutes. So remaining time is 0.8. Okay, we have finished G. We still have H. H needs 0.3 minutes. So the remaining unused time in workstation 4 is 0.5. It is ideal time. Add all of the ideal times, it will be 1 minute. Okay? So, assign tasks to workstation diagram. So we have taken A, B, C in workstation 1. E and D in workstation 2. F in workstation 3. G, H in workstation 4. Okay? So be careful about this one. Number of workstations multiplied by the cycle time must equal to all tasks time plus total ideal time. We have 4 workstations, as I have said before. Okay? We have 4 workstations. Number of workstations is 4. Multiplied by 1.2 is the cycle time. Equal to 3.8 total tasks time plus 1 minute ideal time. Okay? They are both equal to 4.8. So our solution is correct. Percentage of ideal time. Very important to count the percentage of ideal time. Equal to ideal time per day for all of the workstations divided by number of workstations multiplied by the cycle time. So idle time, as I have said before, is 1. Divided by, I have 4 workstations, I have 1.2 cycle time. So equal to 0.2 or 20%. To count efficiency rate, 1 minus idle time rate. So 1 minus or 100% minus idle time rate. So efficiency of the line is 100% minus 20% idle time rate equal to 80%. So we are using only 80% of the available time. Problem number 2. We have already tasks and the diagram given in the exercise. Okay? The task shown in the following precedence diagram are to be assigned to workstation with the intent, of course, we all the times intend to minimize idle time. Okay? Management has designed an output rate of 275 units per day. Assume 440 minutes are available per day. Determine appropriate cycle time. Appropriate cycle time is the available time, as we have said, divided by output rate. 440 divided by 275. Idle time, cycle time is 1.6. So any workstation time is 1.6. Number of workstations. Theoretical number of workstations. The total time for all of the tasks is 4.2. Okay? Divided by the cycle time equal 2.625. Rounding to 3. Okay? In this exercise, we have to add something called positional weight for every task. How we do that? We must go backward from the right to the left, adding the task time. So to get positional weight for A, we have to add the time needed for I, which is 0.3, plus H, which is 0.5, plus G, 0.1, plus E, 0.2, plus C, 0.4. It can get the positional weight for A, 1.8. Okay. Also, you must add the needed time for A, 0.3. It will be equal 1.8. To get the positional weight for P, add all of the followed task time plus its time, the B time. So 0.3 plus 0.8 plus 0.6 plus 1.2 plus 0.6 equals 3.2. So, how to assign tasks to workstation? As I told you before, workstation time is 1.6. Which one must be taken? A or P? Okay? The one who has the highest positional weight first. So we have to take P, because the positional weight for P is 3.2. So, and B needs 0.6 time. So remaining time is 1. 1.6 minus 0.6 is 1. So eligible A or D. Okay? So we will take A. Why? A has many followed tasks than D. Okay? So A. And the A needs 0.3. So 1 minus 0.3 equals 0.7. C or D? We will take C. Why? Because C has many followed activities, many followed tasks. Okay? So we will take C, 0.4, remaining 0.3. E or D? Okay? Also E has many followed tasks. So we will take D. Okay? Remaining 0.1. G or D? Okay, we will take G. Okay, remaining 0. Okay, and G needs 0.1. So no idle time in workstation 1. Workstation 2, 1.6. So we have to take D. before anyone remaining else. So D is 1.2, remaining 0.4. And F needs 0.8. So we can't take F, a remaining time idle. Workstation 3, its time is 1.6, look like the cycle time. Okay? F needs 0.6, remaining is 1. And H needs 0.5. So we will take H, remaining is 5. I needs 0.3, remaining is 2. So it is idle time. Count all of it, 0.6. Okay? How to assign tasks to workstation? Workstation 1 has taken A, C, E, G, B. Workstation 2 has taken D only. 3 has taken H, I, F. Okay? Process layout. To do process layouts, we have many departments. Okay? We have to put department in a place to decrease the handling cost between the departments. The semi-products, the raw material which move around or from to any department. It's called process layout. This one allowed in job shop, allowed in batch processing. Okay? Fixed position layout. Fixed position layout, it is a layout in which the product or a project remain stationary in one place, and workers, materials, equipments are moved around the product as needed. Nature of the product dictates that this type of layout look like big ship or bridge or construction process. Okay, it has high weight, big size block, large, it look like large construction projects. Okay, this is chapter 6 product layout.